Hi class, this is lesson 10-1, area of rectangles and parallelograms. Let's go ahead and start and look at the purpose. Purpose for today is to estimate the area of irregular figures and find the area of rectangles and parallelograms. Go ahead and copy that down. Then I want you to go ahead and turn to the back of your composition books and write the one term that you'll need a definition for. That's the word area. Area is the measure of the surface covered by a figure, and it's measured in square units. We'll talk about what that really looks like in our examples. Go ahead and turn toward the front of your composition books again, and right underneath purpose in two-column form, write example number 1. Now, I don't intend for you to draw this first example, actually. I just intend for you to listen to what's happening. Here we have an irregular figure, and on top of the irregular figure, we have superimposed this grid to help us count how many square units approximately there are. First thing we do is we take a look at the areas of this figure which fully engulf or are filled into one of these squares. So we're looking at full. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 that are fully inside of those grid squares. Then we look for the ones that are mostly or almost full. And those are the blue ones. They almost fill the grid squares. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 of those. And then we look for the ones that are halfway filled. The grids that are halfway filled are indicated by the green, and there's 1, 2, 3. So we're going to include that as a grid square, which means the ones that are less than halfway filled are not going to be counted. Again, this is an estimation. When we add these together, 16 plus 11, 27 plus 3 is 30. Our estimate for this is 30, in this case, miles squared. There's 30 of these, approximately 30 of these grid squares that are a mile by a mile that fit into this irregular figure. Example number 2. Here we're going to look at the area of a rectangle. The area of a rectangle, the formula for that is area equals length times width. In this case, we have a rectangle that is of 4 units by 3 units. When we write down the formula for the area, it's area equals length times width. We substitute the variables with the measurements, and area equals 4 times 3. Area equals 12. 12 what? In this case, it's just square units. And we can go ahead and put units squared as our label. It doesn't mean 12 to the second power. It does, however, mean that this is part of a label indicating area, unit squared. Now, when we look back at this figure, we see that it is indeed 12 squares inside this rectangle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's where the idea of squared units comes from. Squared centimeters, squared miles. It's because it represents the number of squares inside that figure. Here we have a rectangle that is 13 by 8. We write down area equals length times width. Area equals 13 times 8. And when we finish, 13 times 8 in the end is 104. 104 what? 104 meters squared. Example number 3. Example number 3 is an area of a parallelogram. So we're going to do some pretty cool manipulation here. We know that the area of a rectangle is length times width. The area of a parallelogram is base times height. And I can show you that this parallelogram's area is the base here plus the height. The height is perpendicular to whatever you call the base. Height, base, multiplied together gives you the area of a parallelogram. How can I prove to you that works? Well, I'm going to cut this section off, which is a triangle, and then I'm going to move this section over to the other side. And what does it form? Well, it actually forms a rectangle. And we know for a rectangle, the area of a rectangle is length times the width. Well, the length here is the base. The width here is the height. So it's actually base times height. Go ahead and return this so you can see it. Here we have a parallelogram. We're going to go ahead and write down the formula. That's how we started. Base times height. Area equals the base, which is 2 1/3, times the height, which is 3 1/2. I'm going to go ahead and skip some steps here and go right to the answer. The answer will be 8 1/6. And then the label will be inches squared because we're dealing with area. Of course, in between this step, this line, and this line, there are a couple different steps. We're making these into improper fractions and multiplying the numerators, multiplying the denominators, converting it back to a mixed number to where we have 8 1/6 inches squared. Lastly, it's to complete the problem. Here it says a rectangular park is made up of a rectangular spring-fed pool, indicated by the blue, and a limestone picnic ground that surrounds it. The rectangular park is 30 by 25 yards and the pool is 10 by 4. Now what's the area of the limestone picnic ground? So what we're looking at here is we're trying to figure out what's the area of the brown. Just the brown area around the pool. In order to figure that out, we find what the area of this entire rectangle is, and then we subtract the area of the pool, which should give us just the area of the brown. So first we're going to take the area of the park, which is 30 by 25. And I'll go ahead and leave you to figure that out. And then we're going to take the area of the pool, which is 10 by 4. So 10 times 4. And this is the pool. Once you've found these two answers, you'll need to go ahead and subtract the area of the pool from the area of the park, and you will find what just the area of the brown picnic ground is. Okay, we'll see you tomorrow.